Hi, how you all doing? Right, today I'm going to look at straight line graphs, okay? Now I should tell you that everything I'm going to do in this video is essentially GCSE work, although it is aimed at A-level lessons, okay? The only thing that's going to be new is just one equation, which I'll give to you. That's the only equation that you get that's new, that's not in GCSE. Everything else is just basic GCSE level, okay? You should know this already, y equals mx plus c, that's the equation of a straight line, where of course the m stands for the gradient, the steepness of the straight line, and c stands for the y-intercept. Okay, that should be known already. Okay, but what I'm going to do with you is introduce to you another equation that we're going to come to use instead of y equals mx plus c throughout our A-level course. Okay, and to do that, I'll give you a reminder of how to find the gradient between 2 points. Just a reminder. Okay, so let's just use a different colour. Okay, let's be bold. Let's use a different colour for this, shall we? There we go, blue. How's that look on your video screens? So you remember this? Okay, so the triangle approach, I suppose, the right angle triangle approach to find the gradient between 2 points. So choose 2 points, line to line, work out the difference in y coordinates, difference in x coordinates. Yeah, so that is often called the change in y over the change in x, and that is the gradient, of course. The m that we use in the y equals mx plus c. Okay. Now what I'm going to do is I'm going to label that point there with coordinates x, y, and I'm going to label, whoops, this point here with coordinates x1, y1. Well, what's the difference between them? x1, y1, okay, when it's written like that, that is a fixed point that lies on the line. So that's a point you know that lies on the line, x1, y1. It could be the coordinate 2, 3 or 1, 5 or something like that, okay. xy, okay, x and y stand for variables in this case. In other words, it's an unknown coordinate point that lies on the line somewhere, okay. In the y equals mx plus c equation, the x and y, those are variables, you see. And when you've got a value of x, you put it in, you can work out a value of y. Same thing here, those are variables. What I'm just saying is that that's a fixed point that lies on the line. That's more of a variable line. Okay. If you don't understand that, don't worry. Okay. I just wanted to explain what was the difference between these two letters. Now to find the gradient, we're going to do a difference in y coordinates. So we do that, subtract that. So this bit here will be y minus y1. Yeah, that, subtract that. And this bit here, the horizontal distance, will be that, subtract that, x, subtract x1, something like that, okay? And so the expression for the gradient, which we use as m, expression for the gradient will be that divided by that. So y minus y1 over x minus x1, okay? What I'm going to do is I'm going to multiply both sides by x minus x1, bring this over there, okay? So we have m, and then in brackets x subtract x1 is equal to y minus y1, okay? And what I'm going to do is I'm just going to rewrite the order. So I'm going to put that side, that and that side. So just rewrite it like this. Y minus y1 is equal to m x minus x1. And that is it, okay? That is the equation of a straight line that you're going to come to use more often in A-level maths now, okay? So that one more GCSE style, okay? But this one you're going to find so much easier. Now, a bit of a plea here. Please, no matter how comfortable you feel with that, use this one instead, okay? Trust me, you know, you'll benefit from it, okay? And I'll give a few examples in another video as to why that one's actually better, okay? But that's the equation you should use, okay? So y minus y1 equals mx minus x1. So from now on, in my future videos, and of course in my lessons, when I ask what's the equation of a straight line, that's the answer I want. Okay, I don't want that one anymore, that's the answer I want. Okay, and what I've done is I've just shown you the steps as to why that actually works. You don't need to know that particularly, okay, but just try and memorise that equation from now on. Okay, so in terms of the straight line graphs units, yes, you still need to be aware of that, okay, because obviously if you've got it in that form you can write down the gradient, the y-intercept. But that's the one you want to use in subsequent work, okay? I want to show you a couple of other things. Okay, this is more like a video of here's what you need to know, and then the next video will be just answering some questions related to straight line graphs, okay? So let me just rub all of that off. I'm going to put another straight line back on again. Here we go. Quite commonly, you need to work out a distance between 2 points. Okay, so I'll put the 2 points back on again. Okay. Now, if you want to work out a distance between 2 points, those points are normally fixed. Okay, so I'm going to call that coordinate x1, y1 again. But this one, if we're given a fixed point, I'll call it x2, y2, because you want to work out a distance between two known points, okay? Well, if I show you the right angle triangle again, if you're talking about distances this time, then you use Pythagoras' theorem for that, okay? How does that work? Well, if I label that distance from there to there as d, okay, then I think you can see that if you do d squared, you'll get that squared plus that squared. Now this one, in terms of the y coordinates, will be y2 minus y1, and this one in terms of the x coordinates will be x2 minus x1. Okay, so we'd have, doesn't matter which order you do this in now because you've got to square them both and add them together, but you're going to have that squared added to that squared. Okay, y2 minus y1 squared, and that's how you work out the distance. Okay, if I want to give you a formula for just what the distance is, you'd obviously take the positive square root of that, only the positive, mind, because it's a distance. Okay, we have an absolute value there. So that's another formula that you need to be aware of. Okay, that the distance between 2 points is equal to this difference in x coordinates squared plus difference in y coordinates squared, and then square root it. Okay. Right. Lastly, let me just rub this off again. Often you're trying to work out equations of lines that are parallel to a given line. Okay, so if you've got that line already and you've got the equation of it, great. Okay, but if you want to work out an equation of line that's parallel to it, let's just try and draw a parallel line. Okay, the gradients are going to be equal. Okay, the gradients are going to be equal. I'm hoping you remembered that. Okay, again, I did say a lot of this is GCSE work. Okay, so the gradients will be equal. So for whatever value of m you've got from your first line given there, then that is going to give you the same value of m. Okay, it's just that the y-intercepts are going to be different. Now, what if you've got a perpendicular line? Do you remember what to do with this? Well, I'm going to remind you. This is what a perpendicular line might look like. It's been a right angle, so it's perpendicular. Okay. If I call these gradients m and m1 and m2, that would be better. Okay. Then what can we say about m1 and m2? Okay. Well, I'm going to write it here. So for perpendicular lines, and here's the symbol I use for perpendicular. So for perpendicular lines, can you remember what we say about m1 and m2? The product of their gradients is -1. Okay, the product of their gradients is -1. So I'm going to highlight that as well. In fact, why don't I just highlight all of these? Because I'm in a bit of a highlighting mood today. Don't know why that is. I woke up and I thought, yeah, I'm in a highlighting mood today. Yeah, so for perpendicular lines, m1 times m2 is equal to -1. Okay, so as a pure example, okay, suppose the gradient of this line here was 3, then the gradient of this line here would have to be -1/3. Okay, because you can see that 3 multiplied by -3 is -1. Okay, I'll give you just another simple example. Why don't I choose something like this, 5/4. So suppose the gradient of that line was 5/4. What would the gradient of this line have to be? Yeah, it'd have to be -4/5. Okay, because that times that gives you -1. But can you see a simple way of working that out? Okay, what you do is you take the gradient that's known, you take the reciprocal, so 4/5, and then times it by -1. Okay, and that will always work. Okay, so take that, do the reciprocal, multiply by -1. That will always work. That's pretty much all you need to know for the straight line graphs unit. Okay, do watch my next video, because coming up I'll show you some examples in some typical questions that you'll need to answer using all of this stuff. Okay, see you soon.